Now, in this video, we're going to take up one more case of a simply supported beam carrying a uniformly variable load from 0 at one end and W per unit length at the other end. 0 at one end and W per unit length at the other end to draw the shear force and bending moment diagram for this particular case. So figure shows a simply supported beam capital AB of span length L carrying uniformly variable load from 0 at one end and W per unit length on the other end. So support reaction will be equal to total load on the diagram, total load on the beam will be equal to area of the load diagram, that is the area of triangle, which is half into base is L and height is W. So half into W into L. So here let the reactions at A and B will be equal to RAV and RBV respectively. Taking the moments about the point A. So taking the moments about the point A, so RBV into L, which will going to act in the counterclockwise direction, therefore negative. So that is minus RBV into L plus half into W into L is the high base is L into height is W, half into W into L, and the distance of center of gravity from the bigger end. Since the moment is about the point A is the bigger end, so that will be equal to L by 3. So that will be equal to 0. So taking the right RBV into L onto the right hand side, RBV into L will be equal to WL square by 6. So WL square by 6. Therefore, RBV will be equal to W into L by 6. So you will going to get the value of RBV as W into L by 6. Next, also sigma V will be equal to 0. So RAV plus RBV is equal to area of the load diagram, that is half into W into L. Now you substitute the value of RBV as WL by 6. Therefore, RAV plus WL by 6 will be equal to WL by 2. Taking to this onto the right hand side, RAV will be equal to WL by 2 minus WL by 6. So on simplification, you will going to get RAV as WL by 3. So you are going to get W into L by 3 at RAV. As there is no horizontal load, RAH will be equal to 0. Now we are going to take up the shear force and the bending moment diagram. So consider the section XX at a distance of X from the free and from the support B. SF at XX will be equal to, we want to take that from the similar triangle principle, triangle ABW will be equal to triangle XXB. So therefore, we want to find out the height of this, that is the height of the smaller triangle, because the shear force I need to find out at this section. So that will be equal to, what is that, minus RBV plus half into, so this is W by L will be equal to XX by X. So W into X by L will be the height of this. W into X by L is the height into the base is X. So therefore, that will be equal to minus W into L by 6, because substitute the value of RBV as WL by 6 plus half into WX square by L. So in other words, WX square by 2L, call this equation as 1. So equation 1 shows that shear force varies, SF varies according to the equation of parabola. So when the value of X is equal to 0, so what happens? SF at B will be equal to minus WL by 6. When the value of X is equal to L, SF at A will be equal to, substitute the value of X is equal to L here in the equation 1. So that will be equal to minus WL by 6 plus WL square by 2L. This L and this L will get cancelled. So you are going to get it as minus W into L by 6 plus 2 WL by 2. So taking the LCM and simplification, you are going to get it as W into L by 3. So yes, SF at A will be WL by 3. As the SF varies from plus WL by 3 to minus WL by 6, according to the equation of parabola at a point, it must change the value equal to 0. Where exactly it will going to change? So let this point be at a distance X from B. So you will going to get the X from B. So that means SF at the distance X from B will be equal to at this point. How do you find out that? So that will be equal to minus W into L by 6. So again, plus W into X square by 2L. So is equal to 0. So taking this to the right hand side or the left hand side, whichever way you want. So you're going to get it at WX square by 2L will be equal to WL by 6. So the value of x square will be equal to L square by 3. Therefore, x is equal to L by root 3. As the distance of x is equal to L by root 3, from there, the SF will going to be, the value will be equal to 0. So now, why we are taking that point with here equal to 0? Because SF at that particular point is 0, but we don't know the distance. So to find out the distance, we need to consider that section. If you are considering that, so this is x now. So since it is x, Wx by L, that is the 1, Wx by half into W into x by L, W into x by L will be into x. So that will, therefore, you're going to get it as Wx by 2L only. So that is the same equation as the one what you got for this one. So once the value of n is equal to L by root 3, SF will be equal to, naturally it becomes 0, because once you have substitute this value of x is equal to L by root 3 in this equation, again you are going to get the value of SF will be 0. So then Bm at this section xx we need to find out. What is the bending moment at this section? So that is considering this, so you have positive value. So RBV into x will be equal to RBV into x minus half into W into x by L into x into the distance of center of gravity from the bigger end. So the bigger end is this. So that will be equal to into x by 3. So on simplification, you will going to get, substitute the value of RBV as WL by 6. WL by 6 into x will be equal to minus W into x cube by 6L. So call this equation as 2. So equation 2 shows that the bending moment varies according to the cubic law. So once you get this, so now we want the bending moment at the point A. So substitute the value of x is equal to 0 in this equation 2. So since x term is there in both the parts, so the value of x will be equal to 0. So Bm at A will be equal to 0. And similarly, when the value of x is equal to L, when the value of x is equal to L, so the Bm at A, so substitute this L cube, W into L square by 6 minus W into L cube by 6L. This L in this case will get cancels. So WL square by 6 minus WL square by 6 will be equal to 0 again. So Bm at B is 0, Bm at A is equal to 0. Now we want to get the value of Bm at C, which is at this point, you must get WL square by 9 root 3. So to get that, we need to put the value of x will be equal to L by root 3 in this equation. So which is that equation here? W into L by 6 into L by root 3 minus W into 6 W by 6L into L by root 3, that is L cube by 3 root 3, that is 18 root 3. So that means in this equation, you will going to get it as WL by 6 root 3 minus W or L cube by 18 root 3. So on simplification, I will going to get it as WL square by 9 by root 3. So this is where the maximum bending moment will going to occur, where the SF changes its sign. If you are considering that, you can see the SF is changing its sign at this point. At that point, you are going to get the maximum bending moment, which will be equal to WL square by 9 by root 3. So this is how we will be able to analyze and solve the shear force diagram and the bending moment diagram for uniformly varying load. Thank you.